DC-8 is mission ready.
Looks like maybe it's level now. All right, looks like it's a wings level and rock course.
So the reason why we picked these sites over the desert in California is because they have these dry lake beds there, and they are a very flat area that's ideally suited for our purpose. So we can put a GPS receiver on a car and kind of drive around on these flat lake beds, measure them, and then a few days later fly over the same area with the DC-8 and take a measurement from the air, compare the two measurements, and use the data from the ground to calibrate and validate the airborne measurements.
While the aircraft is prepared for the trip to Chile, the science and flight operations teams are required to undergo specialized safety training, regardless of if they've flown on the DC-8 in the past.
Well, for the DC-8, everybody who flies has to go through basically a safety briefing. We go in a little bit more detail because we do more things on our airplanes than commercial airliners do. From our pilots, they go through survival training, water and land, and depending on where they're going, some of them have been through Arctic. All of our crew members, they all have to go to altitude chamber, water survival, land survival, and what we do here is we just build on that and then try and bring anybody else that hasn't had any formal training up to speed so they have at least a working knowledge of the kind of conditions that can happen if something was to go wrong with the aircraft.
Safety equipment tailored for Ice Bridge is also packed on the DC-8.
Overhead compartments, we've got 20-man life rafts. There's 4 of those on board the aircraft. We have 2 what we call global survival kits, which has different survival items inside of there. For this particular deployment, we also have anti-exposure suits, which if they were go into the water, we'd have enough for everybody on board the aircraft for that.
Once the aircraft and passengers are cleared to fly, it's time to pack up for the long transit flight from Armstrong Flight Research Center in California to the southern tip of Chile. The exhausted team gets an opportunity to rest on the overnight journey to Santiago, where a second flight crew is on standby to complete the journey to Punta Arenas.
To get to this part of the globe, it's about 14 hours of flying. We had pre-deployed a crew to Santiago to join the flight at that point so that the crew that flew all night could then step out of the cockpit and rest. And that allowed us to continue on that next day down to Punta Arenas, Chile, without having to stop overnight.
It's a cold and windy welcome at the Punta Arenas Airport, the mission base for Operation Ice Bridge. The scientists and flight crew will call this place home until the end of November.
We are setting up base stations here at the airport that record the GPS data for various instruments. We're talking to people in the weather office, at the tower, the air traffic controllers, and that typically takes about a day getting everybody settled in here and preparing everything for the first science flight.
With 2 complete flight crews available, science flights are planned on consecutive days to collect as much data as possible over Antarctica.
On a typical Punta Arenas deployment, we have about 300 flight hours, and if we fly as much as we can, which we typically do, we kind of travel a distance in Antarctica that's equivalent to 3 or 4 times around the equator.
I think this is a glacier.
Each day.
I've got rising terrain.
Miles of tally-ho, and I'm going to start climbing here.
Pilots need perfect visibility of the terrain for safety.
We'll clear it. It does get steeper as we get closer to it, so we can catch up a little bit.
Several science instruments need a clear line of sight between the aircraft and the ground to collect proper measurements.
Meteorology is obviously a very big deal with Ice Bridge. It essentially governs everything that we do on any given day. We have to fly down low and near the terrain in order for our instruments to work as they're optimally designed to work. So it means we need clear skies below